Part 2, vertical asymptotes. The line x equals c is called a vertical asymptote of the graph of a function y equals f of x if, as x approaches c from the left or as x approaches c from the right, either f of x approaches infinity or f of x approaches negative infinity. So what does that mean? This notation might be new to you. X approaches c with the little negative sign up here. We read that as x approaches c from the left. So if we have a graph, let's say this is the line x equals c. That means as the graph is getting closer and closer to that line from the left, what's happening to the graph. In this case, it's going up. We can see as x is approaching c, this line x equals c, the graph is going up. So f of x is approaching infinity. If it was going down, it would be approaching negative infinity. And this other one, x approaches c from the right with that little plus sign, just means what's happening if we're getting closer and closer to c from the right. This is the graph of f of x equals 1 over x, and the vertical asymptote is the line x equals 0, because as x approaches 0 from the left, so from the left, as we're getting closer and closer to 0, notice that the graph is approaching negative infinity. And as x approaches 0 from the right, so from the right-hand side, the graph now is getting bigger. It's going up, approaching positive infinity. So x equals 0 is a vertical asymptote. Let's think about how this applies to g of x equals 1 over x minus 4. If we think about this with transformations from the graph 1 over x, which is our original graph here, 1 over x minus 4 gets moved to the right 4. That means the asymptote also gets moved to the right 4. So instead of our asymptote being the line x equals 0, the asymptote is the line x equals 4. When we find vertical asymptotes, we're going to find the asymptote of the simplified rational function. So if we can cancel out like factors, we'll do that before finding the asymptotes. So first thing you're going to do to find a vertical asymptote after you've simplified the function is determine the x values that make the denominator 0. And then the vertical asymptote will be the line equals a, where a is some value where the denominator is equal to 0. Now remember, a graph will never cross or touch a vertical asymptote. If our denominator equals 0, the graph can't be defined there, so the graph will not cross a vertical asymptote. Let's identify the vertical asymptotes of this function. F of x equals negative 4x divided by 5x squared plus 2x. If I factor that denominator, I can factor out an x and I get 5x plus 2. If I were finding my domain, I would find my domain now and say that my denominator can't be 0. So x can't be 0 and 5x plus 2 can't be 0. But before I find the vertical asymptotes, so first I find the domain, then I will cancel out my like factors, and I'm left with negative 4 over 5x plus 2. And now I'm going to find the vertical asymptote. So the vertical asymptotes will be where that denominator equals 0. So where 5x equals negative 2 or x equals negative 2/5. So the vertical asymptote of this function, it has one vertical asymptote when x is negative 2/5. Identify the vertical asymptotes of this function. R of x equals x minus 3 divided by 2x squared plus 5x minus 3. The first thing I'm going to do is factor that denominator. So I have x minus 3 divided by 2x minus 1 times x plus 3. Is that right? So we have 2x squared plus 6x minus 1x minus 3. Yes, so 2x minus 1 divided by x plus 3. There are no common factors to cancel out. So to find our vertical asymptotes, we have 2x minus 1 equals 0, which means that x equals 1/2. That's one vertical asymptote. And x plus 3 equals 0, so x equals negative 3 is another vertical asymptote.